All right, so there is also an alternative way of solving this. We are told that in a class of 20 students, 16 play soccer, 12 play hockey, and 2 do not play any of the 2 games. How many students play only hockey? What if we do not want to use Venn diagram to solve this? We can solve this without using Venn diagram. Let me put out the data. The number of students in a class, that is the universal set, is 20. 16 play soccer, so the number of students who play soccer is 16. 12 play hockey, so the number of students who play hockey is 12, and 2 do not play any of the 2 games. So let me look at the number of students who do not play any of the 2 games. So that means that if I unite their 2 sets, I'm talking about a complement of the 2 sets, that is the number of students in S union H are complement, and that is 2. Now there is a function, or let me say an expression that I can use to do this. The expression is the universal set is equal to the number of students in, or the number of students who play soccer, plus the number of students who play hockey, minus the number of students who play both hockey and soccer, but I have to add those who do not play any of the 2. The number of students in S union H are complement. Yeah, I'm doing this because if you looked at the Venn diagram very well, you would notice that we had something like this. We had S here, H here, X was 16, H 12, but we had 2 also here, and of course we had to subtract the intersection, because of the fact that if we don't do that, we will count them twice, because these are people who are playing both soccer and also hockey. I think in one of the formulas, in one of the questions that I solved, instead of writing this, we had 2 sets. We had a set A and B. Let me use the set S and H as we have here. It would have been something like this: S union H is equal to the number of elements in S plus the number of elements in H minus the number of elements in S intersection H. So why am I now using the universal set? Now in this instance there is no complement, but the moment there becomes, or there is a complement, then you have to consider the entire universal set, because considering only the union of this means that you are neglecting the complements. So that is the reason why I didn't write the number of students who play soccer and hockey. Instead I wrote the universal set. Of course this is equal to this if there is no complement, but here there is a complement, so I have to be very careful. Now the universal set is 20. The number of those who play soccer is 16. Number of those who play hockey is 12. Number of those who play none of the 2 games, I don't know, so let it be X. So let me put X there, minus X. And the number of those who do not play any of the 2 games, that is S union H complement, is 2. So let me simplify this. 16 plus 12, I'm getting 28, plus 2, that gives me 30, minus X. So as I did say, I don't want the negative, so I will send it to the left hand side. I will have the X here. The sign here will change when it crosses the equal sign to positive. I have 30 here already, so I write it. I bring the 20 here, I have negative 20. So when I subtract 20 from 30, I get 10. So there was no need writing, drawing the Venn diagram. So there was no need drawing the Venn diagram and using the Venn diagram. I just found the value of X, but X is the intersection. But I'm asked to find the number of students who play only hockey. So this is the tricky part that you have to see. Now the entire hockey, I'm told entire hockey is 12, and I'm told the intersection of the hockey and the soccer is also 10. So if I want only hockey, then I have to take out the intersection, which is the 10, so that I get 2. So the answer becomes the D. So that is an alternative way that you can also use to find the number of students who play only the hockey.